Okay, so we're recording. Nice. So basically, when the question is a little confusing sometimes, what's really helpful is to look at the test cases and figure out what exactly the test case is asking. So here it's saying, let's look at my or first. So basically, it's saying it expects it to be a function. And when you call it, it expects the return value to be the first value if it's truthy. Um, it expects it returns the second value if it is the first truthy value. So if the first value is not truthy, null is falsy, so is an empty string, so is zero, I believe, and undefined. Those are all falsy. And a string is truthy as long as it's not empty. So in this test case, since this first argument is falsy, it'll return the second argument. And here, if the first and the second argument are falsy, then it'll return the third value. And finally, if none of them are truthy, so empty string, zero, null, then it returns the last value. So basically, this just is a long way to kind of get across the point that if you're using ors, like this syntax here, basically, if there's one true statement, then the whole thing will be true. So that's kind of like the big idea here. It is a little bit contrived, but that's sort of the main point, is that usually in a conditional, if you have a bunch of or statements, only one of them needs to be true for the conditional to be entered. So that's the main idea for this, but we can just go through it. So my or, it takes the first, second, and third argument. And basically, if the first one is true, then it'll return that it's true. So right here in this example, so if first, so even though first is not necessarily a Boolean, it'll become a Boolean because it's within an if. And so it'll basically get transformed into a Boolean, essentially. And so since a string that's not empty is truthy, it'll become true. This will basically become true. And then we can just return it. If second, so we only get here to this line 7 if first is false. Otherwise, we would have returned it already. So we don't need to do another check to say, oh, if not first and second or something. We don't need to do that because we know that the function would have already ended being, the function would have stopped running if first was false. So we know first is false here. So here we return second, and if third, that means that second and first were both falsy. Then we return third. And then here we can just return third, because if all of these ifs don't run, then we know that basically they were all false. And then we just return the last argument. So that should handle the first couple test cases of or. But basically, we can get lost in the weeds here. The main idea, again, is when you have two conditionals, like if it's sunny or it's warm, then go outside. It's mainly saying that, only one of these needs to be true. Even if it's not sunny, it just has to be warm. Or if it's not warm, it just has to be sunny for us to go outside. That's mainly the point of what this is trying to get across. And also that, even though this value may not be true, it may not be a Boolean, it will still be evaluated to either true or false based on what it is. So if it's a string, if it's a number that's not 0, or if it's the value true, they'll all be true. If it's an empty string, if it's 0, or if it's undefined or null or false, then they'll all be false. So those are kind of like the two main ideas here. And is along the same lines. So we'll look at the test cases here. It's saying it's a function. It returns the first value if it is the first falsy value. So since this is falsy, it's returning it. Returns the second value if it's the first falsy. So 20 is truthy. The second value here, it's falsy, so it'll return the second. And it'll return the third value if it's the first falsy. So 0 is falsy. All of these are truthy, so it'll return 0. And if they're all truthy, then it'll return the third. So it's pretty similar to the first, but it returns falsy values, I believe. Yeah. So my ands will have first, second, third. And there's a question right now that's in the chat. So Elizabeth asks, could we write this with else, if else? Yeah, you definitely could. You can do, so for example, I just like to keep it all on the same indentation, but technically you could do something like else, if, second. But in this case, it's pretty much, this else is pretty much implied just because we return here. And so it's basically like doing an else. But let's say there was no return here. If there was no return and we just did something like, do something and we didn't return, then we would need an else if, because if first was truthy and second was truthy, then it would do both of these things. So because there's a return, we don't need to put an else because it will never go to this line. So there's an implicit else. But if you want to be safe, then you could put an else here so that you know for sure that only one of these conditionals will ever be run. It won't be multiple conditions that are run. So yeah, like to answer your question, Elizabeth, you could have done this with else if second, and then else if third, and then else return third. That would be also valid. Let's try to run it again. Yeah, that also works, but I just like to have it all on one line, all on one indentation if we return from the if. So if we're always returning within the conditional, then we don't really need an else if because it's pretty much implied by the fact that when you return, you're done executing that and you'll never go into the other conditionals to even evaluate the following conditionals. There's another question. So why can't we say if first equals true, if second equals true? Just to clarify, I know this doesn't work because tests don't pass, but I don't understand the logic. So I think if you say if it's double equals, I believe there's typecasting that happens. I'm not 100% sure because double equals is usually avoided just because there is that typecasting that happens. So it can be confusing a little bit. So I think what I mean by that is, you guys probably can't see, but let me try to do this. Yeah, so if you did something like, let me do it on a bigger screen. So if you do something like, if you wanted to evaluate 8 equals 8, I think if you do 2 equal signs, it does typecasting. So it'll evaluate to true, which is kind of confusing. Like a lot of times you don't want this to happen. So we like to use triple equals in JavaScript if you want to do comparisons so that the types are also compared. It's not only just the value that's compared. So we try to avoid this as much as possible because it's a little confusing sometimes, but I'm not 100% sure what happens if we put like a string and then put that equal to true. Let me try this out. Yeah, I guess it doesn't. So I guess it doesn't convert this string to be either true or it doesn't convert it to a Boolean. So if you wanted to cast something so when you put it in a conditional, it will always automatically just cast it. So if you have let truthy string equals to ABC, and then if you say truthy string, does anyone want to guess what this would log? If I put if truthy string. Yep, it'll log here because it'll basically cast this to be truthy. But I think if you wanted to do that without, like I think you could do something like Boolean, and this would be the same thing. You're like converting it explicitly. Like this is implicit. This is implicit. It's happening under the hood. But if you want to be explicit about it, you could just cast it yourself. And in that case, I think you could do something like if Boolean truthy string equals true, console log explicit implicit. Yeah. So if you wanted to do something like what Jackie said, like with the comparison, you could convert it yourself into an actual Boolean, and then you could put that within the if, but it's redundant because it'll happen for you out of the box in terms of whether this value is truthy or falsy. So it's a little weird though because you just it's kind of like a trust fall where you have to just trust that it's true or false even though it's not really true or false. But if you put it within an if, it'll always just evaluate to that. So, but if you wanted to be explicit about it, you could technically do this, and that would work. So back to my and. So yeah, this one is basically saying, oh, if not first, so if first is falsy, or you could say if Boolean first equals false, if the not is confusing, but it's a little shorter, so I'll just use it. So if not first, then return first. Now I could do an else here, but I don't need to do an else here because because I return, basically it will never run this if statement unless this is false. So I technically don't need to put an else there. Return second, and then if not third, return third, and then here return third. But basically, this is another contrived example. The main important idea here is for ands, they both need to be true. So, before it was just like, oh, if it's warm or if it's sunny, go outside. But if you're really sensitive and you just hate going outside unless it's really perfect, then you might say, oh, if it's warm and sunny, then go outside. So really you want it to be warm and sunny. If it's not both of those, then you won't go outside. So it's a little more of a strict case here than here, where basically you're being a little more loose, saying, "Yeah, I'll go outside in pretty much, decent conditions." Whereas for this case, the conditions have to be perfect for you to go outside. That's basically the main idea. It's a little confusing. Even when I read it, I was confused. So the only thing to do when you're confused is really to try and look at these test cases and try and figure out how to pass them one by one if it comes down to it. Because sometimes reading this won't be enough. So yeah, are there any questions about this problem?
Not this problem specifically, but so for the entrance test, are there questions like this where we would be given specs?
For the entrance test into the program,
Yeah.
it's similar to this. It will definitely be a little bit more involved. The so this, I believe there's a assessment that you do on your own remotely before you get the interview, and that assessment has 6 questions, around 6. And so the easiest one might be like around this difficulty, and then it'll get progressively a little bit more challenging, but it will
What I
be.
mean is like say I couldn't follow the initial question, would it have specs that I could look at and see to kind of gauge what it's asking me to do?
um I'm not sure if it's this explicit. It might be kind of, some might be hidden, but I believe they'll give you like very clear examples. So it might not be like the test spec themselves, but they might say, "Oh, like if I put this as an input, this is the output.
Okay.
If I put this as an input, this is the output." But I think for certain, I can't remember off the top. It's been a long time since I took that, but I think for certain cases it might hide some of the exact test specs, but um, you're able to see very clear examples.
Okay.
Yeah. Great question. Let's move on to, let me check what the other question was. Only one. Let's see. So write a function, only one, that accepts 3 arguments of any type. Only one should return true if exactly one of the 3 arguments are truthy. Otherwise, it should return false. So here it's saying only one is a function. I'm looking at the test cases, but I mean, in this example, it says only one, false, false, true, should return true only if only one of the, yeah, okay, so if they're all false, then return false. So let's see, 1 1 0, that means returns true if only the first value is truthy. Returns true if only the second value is truthy. Returns true if only the third value. Yeah, so for this case, I mean, we can't use equality operators. So I'm thinking it's going to be, from what I'm thinking, I would just compare, if 1 is truthy and 2 and 3 are not truthy, then I would return 1. And then I would do another comparison to see if 2 is truthy, but 1 and 3 are not truthy, then return true. And then if third value is truthy and these are not truthy, then return true. And then if they're all, and then else return false. So in this case, only one, first, second, third. So I would maybe do something like if first and not second and not third, what would I return in this case? Any guesses? Yep, first. Because, yeah, these two are falsy. We know that they're falsy because we're explicitly checking that. And then I'm going to return first. And then here, if I do second and not first and not third, then what should I return in this case? Basically, return second, and then the pattern is pretty much the same here. If third and not second and not first, return third. There might be like a more elegant way to check this. Like, for example, if you might be able to do some logic to deduce whether or not, if this condition was false, then you kind of you can do some guess and check. You can do some, you can remove certain possibilities so that I'm not checking every single time all of the variables. But yeah, I think this is one way that it's super explicit and super clear, like what exactly I'm doing at each step. And yeah, I guess I have to return true. Yeah. So I think Raymond said we expected to return Boolean value. So yeah, that's the mistake that I made initially. I just returned the actual value, but they want a Boolean in this case, so they wanted true. Are there any questions about this problem? If not, then we'll go on to our final one, which is 0, dark 30. And we'll evaluate this guy. So what this wants us to do is basically it wants us to create a new number without zeros in it. And I really like, so if there's an edge case like this, I would pretty much want to handle it first and get that out of the way so that the function doesn't need to do extra work. So here we just give it a number. This parameter could be anything. It could be num, it could be x, it could be input, it could be argument. You can call it whatever you want. And I would argue that the first order of business is to just handle this edge case. If the num is 0, then just return NaN. Else, we actually have to do stuff. So does anybody have any suggestions what I could do first? What kind of approach I could take in order to remove all the zeros from this input? If not, it's fine too. But I would, yeah, perfect. So Jessica said we want to change the number to a string. That's exactly what we want to do, because we needed to basically manipulate certain characters in the string, basically removing the zeros. And so we can't really do that with numbers. We can't really remove a number from a specific index like we can from a string. So it's just easier to change this into a string. So yeah, turn the number into a string and iterate through. Perfect. So whenever we create a new string, then I always want to initialize this new number or new string. Call it a string for now because it's a string. Because we need to build it up. But in order to build something up, you need to start from somewhere. And so you always need to initialize some type of initial value so that we can add to it. And we'll say old string is num.toString, converting it into a string. And then here we'll start at 0, go until the length of the old string. And here I can be explicit and say let old let character equals old string at I. And then here, any suggestions as to what I should do? I have that character, so I have, in this case, for the example 1, 2, 3, 2, I have 1 as a string. That's going to be my first character, old character. So yeah, perfect. I love the suggestions, all awesome suggestions. So yeah, I'm gonna just check to see if the old character is equal to 0. And sometimes it might be, you might have put this, but it's a string at this point, so we have to check if it's 0. And well, I'm just gonna check actually if it's not 0, because I don't want to put an extraneous continue or something. I could put a continue there, but I don't have to because it'll continue anyways. So I'll check the opposite case where I actually need to do something. And yeah, we just add them to the string. So new string plus equals old character. Else, I don't really need an else because it'll just continue if it's 0 and it won't add. So, you know, the less code you have, usually the better. That's not always the case if you're trying to make things really clear and you want to add a little bit more code to make things really clear instead of doing like a fancy one-line solution or something. It's always best to be as clear as possible, but if you can avoid extraneous code, like extraneous continues or something, then it's usually best to just keep things simple. And here, what is the last final thing we need to do? Because we have this, so technically if we had 0, 1, 0, 2, 3, 0, 2 or something, then right now we have removed all the zeros. It's 1, 2, 3, 2. Yeah, we need to return, convert it back to a number, exactly. So we have to return parse int or parse float new string. And I use parse float because of the second example right here is 20.23. I think you need to parse the string as a float to handle strings with decimals in them. I think this should work. But yeah, important things to remember here are whenever we need to build something new, like whenever they say, oh, return me something with this removed. That's a very common question. Or return to me something where, you know, we reverse the order of this, or we take out all of this, or return to me something with this string, but like stuff added to it. Then usually you want to create this like new string and then start doing operations to it while iterating through the old string in some way. This is a pretty common concept. Can you talk briefly about why so Cassie asked why we use toString instead of string. So why did .toString instead of string? And to be honest, I'm not 100% sure what the differences are. Other than that, string is its own function that takes in a parameter, whereas toString is a function that's on the number itself. So there are two different ways of pretty much doing the same thing, in my opinion. Unfortunately, I'm not 100% sure what the two differences are, but I'm sure if you could look them up on Google, it would have an explanation. But to me, I never thought to go super deep into what the differences of the two were. But what I do know is that one of them, this function, this is basically a function that's being called, is attached to the number object. So we can call that function directly from the number, whereas string is its own function that's globally available in JavaScript, and you could just coerce using that. Um, yeah. Are there other ways to manipulate? So Winston asks, are there other ways to manipulate numbers like this? Or do you have to coerce them to strings and then coerce them back to numbers? If you're really, really good with numbers, you could probably do like some crazy addition or subtraction to somehow, you know, or division or multiplication to remove all the zeros in some way, but you can't iterate through numbers and remove numbers at a specific index unless they're turned into a string. So to answer your question, there probably is a different way to remove the zeros by doing some fancy division multiplication combo that I have no idea how to do. But if you want to do something as granular as this, then usually you will have to do the coercion, because there's no way to say that, oh, like, I haven't tried this in a while actually, but let's try it out. So if my number is like 2020 or something, let me try to access this. Yeah, like you can't, wait. You can't access a specific index of a number. Just make sure. Yeah, it's undefined. So yeah, you can't really manipulate them like you would with granularity as you can with a string. So you kind of have to turn it into a string. Can strings and numbers be turned into arrays? Yeah. We haven't gone over arrays yet, I believe. I believe that's coming up soon. But you could do something like I believe it's split. Let's see, num.split empty string. Yeah. So you can do stuff like turn this string into an index or into an array that has at each character at a specific index and things like that. But you can't do that with a number, I believe. Can you? Yeah, you can't do that. So strings have a lot more flexibility and a lot more features than numbers do. But yeah, are there any other questions? Keep them coming. Could we have used number to do the string conversion with the decimal? Let's find out. I'm not 100% sure on all the nitty gritty of this because usually, to be honest, when I'm working with this, I just tend to look at the documentation and I don't have this stuff 100% memorized, because usually when you're working with this stuff, you can just look online and see which method would be the best for this case. But you might, yeah, for this case it works. There's a million different ways to do these conversions, so yeah, this works too. But Usually you can just check the manual when you're faced with a specific task like this. But yeah, I wouldn't get bogged down too much in like conversions and like which like getting too specific in those kinds of minutia, just because if you're asked a question and you're stuck on some little conversion, that's not as big of a deal. But just big main ideas, like whenever you need to create some new um, variable or value, you should always instantiate something and sort of add to that and aggregate into that. Those kinds of higher level concepts I think are more important. And if you have like an edge case that you want to handle that quickly so that you don't have to do all this stuff and then realize that your number is actually zero when your code has actually ran a bunch of more lines than it needed to before it can just like return something. So just picking up on these higher level concepts I think is more important than like the difference between using string versus toString. Those are all important in their own way, but for now I think it's better to focus on like the high level of um, things like when you're iterating through a string, sometimes it's very helpful to create a variable to what that index actually represents, because if you just did something like this, you could do that, but it's kind of descriptive in this case because you kind of can deduce that this is a character, this represents a character, but in other instances you might not really know, and it might be helpful to give this a name so that you know exactly what you're comparing versus like the index of something, which is a little more mysterious. So it's helpful to do things like this, and it's helpful to, I could have very easily said, if it's zero, then just continue. Else, if it's not zero, then do a bunch of stuff. But really, this is like unnecessary because it'll continue anyways if it reaches the bottom of the for loop. So you wouldn't want to add more code than needed, and just, yeah. So those kinds of high level concepts, I think, are important. All right. So there's no other questions. You can ask them right now, but if there's none at this point, then we'll go on to the lecture, which is scope, which is very important. Very, very important. And it'll be used in all facets of your coding career, and it can get very advanced. Using this can allow you to do a lot of very cool things. But basically, we'll go over the different types of scope, what scope actually is, and some best practices. And it's always good to take these best practices to heart, just because there's definitely a reason why they're best practices, and you could avoid a lot of headache in the future by abiding by them. So yeah. But then again, best practices, sometimes you can't avoid breaking the rules. So rules are there to be a guide, but they're never going to be, like, they're never going to be absolute. So scope basically means which variables are available to be accessed by your code at a specific point in your code. That's basically all it is when your JavaScript engine is evaluating through the code, it goes, from top down, and it's running through code. And when it runs a function, scope is basically going to tell your engine which variables it has available to it. And if your function tries to access a variable that it doesn't have access to, then your code will stop running. It'll throw an error. So yeah, that's basically what scope is. So this is a very simple example, but basically wow is, when we evaluate this code, wow is available in the scope of this basically global function that's being run. And so we have access to it and we can log it. It's um, accessible to the engine. So global scope, to go over global scope, basically a global variable can be referenced from anywhere in your code. So once you declare a global variable, then no matter how deeply nested your function is, or if you have a function that gets created within a function, or if you have a bunch of conditionals that you nest a million times, even in that most deep layer, you can always have access to that global variable. So yeah, and it can't be accessed until the assignment operation occurs. So does anybody have any guesses as to what this will log? Yeah, I believe it's undefined. It might be an error. Let's see. Yeah, it's undefined. Very, very good call out. So basically, when we first try to access wait for it, I believe this line 7, wait for it, gets hoisted to the top. So it's almost like on line 4, there's a let wait for it with no assignment. And so then on line 5, when you log it, it's undefined because you haven't assigned anything to it. Then in line 7, it actually does the assignment. And then in line 9, it'll actually log what we expect. Yeah, Elizabeth said JS reads line by line. That's for the most part true, but there are some nuances to that. Like for example, even though line 7 is let wait for it equals here I am, the let wait for it actually gets hoisted up to the top. Even though it's on line 7, it's almost as if it happened in line 1. The actual let wait for it, so the left side of the expression. So it does read line by line, but there are some nuances to that. And we'll learn more about that later on with hoisting. So, and Elizabeth asked, is this how let and var differ? Yes, this is one of the ways that let and var differ. Not necessarily the fact that it's hoisted, because I believe that var is also hoisted, but I believe um, let is more strict in terms of if you declared a let within an if, for example, so block level, um, it won't be accessible outside of that if statement. But if you declared a var within the if, then that would be accessible outside of the var. So outside of the if. So var is a lot more loose in terms of how it's scoped versus let, which is a little more strict in terms of how it's scoped. So that's one of the ways that they differ. So variables declared inside of a function are locally scoped and they cannot be referenced outside of the function. So any guesses as to what will be printed to the console when we run happy function? There will be an error, but first it'll actually log the message, because we have let message equals I'm so happy, and then we log that when we call the function. So we will see I am so happy. But when we try to log the message itself, message doesn't exist outside of the function, so we'll run into an error. So it actually logs when we first call that function because message is available within the local scope of happy function, but it's not available outside of the scope. So yeah, basically with scope, you can, for the most part, access outside in, but you can't really access inside out. And that'll become more clear as we get further into this. So this is an interesting scenario. So okay, so Arthur asked, why is console log a reference error? It's a reference error because message doesn't exist outside of the function. So let me go through an example here that might make it a little more clear. So we have, let and then wait. Just take this out. So basically, how much and console. In the context of the slide before where it was undefined. Let me see. You mean in this one? Oh, yeah, we can go over that one then. Let's see. But just as a reminder I'll just go over this since I already did it. But basically, money is not defined outside of the function because we're outside of each function creates its own scope, its own environment of accessible values. And so within the function, we have that money, but outside of the function, we don't because we haven't declared it. Now we could do something like this where we could say let money equals, 5 or something. And in this case, it would work because this money is 5 because it's outside of the function. It's in the global scope. And in here, it's locally scoped. So it'll basically look inside out. So it'll first, I'll go over this more later, but basically if money is, it'll basically look for the closest one. So if I remove this, it'll print 5,000 because it's the closest one. But if I remove this, then it'll keep looking from inside out. It'll keep going out like through the layers of an onion, and it'll just give me 5 if I remove this. But if I add this, then it'll use the closest one. So it's kind of lazy. Like it only looks for the closest one, and when it finds it, it uses it. If it doesn't, then it goes further and further, but it doesn't want to. And to answer your other question, Arthur, in terms of why this was undefined, it's because this assignment happens in line 7, but in line 5 the assignment hasn't happened yet, so it's just wait for it. So for example here, let's see, name, and then if I have let name equals David, and then if I have console log name after name, basically what happens in this case is it's almost the same thing as doing like let name, putting that at the top, and then doing the actual assignment at the bottom. It's pretty much the same thing because this instantiation gets hoisted up to the top, but that is happening under the hood. So this is the same thing. Oh, I guess with let it's not the same thing. So I may have gotten mixed up. So let might not even be hoisted to the top. I think it's var that's hoisted in that case. Yeah. So the slides are a little bit off, but this should be like not even undefined, but some type of error. And let and var will get hoisted. So it's with var, it's the same thing as doing this, which means that this gets hoisted to the top. But if you use let, then it doesn't get hoisted. And I'm glad I did this example because this actually just breaks and says name is undefined. So I believe the instantiation and the assignment happens at the same line. So if the let is a const, so in this case, if the let is a const, in this case, it shouldn't matter. Const just means that you can't reassign. So it's pretty much should focus the same as let, but const just means you can't reassign. So basically, let's say I did something like this: let David, and then name equals David. And this works with let because it's using let. But if I did const, it shouldn't work because you can't really reassign a const. So let's just try assigning it for now. And then you can't say like name equals new name or something because it'll say like, oh, like reassignment to a constant variable. So you can't do that with a const. So when you declare a const, you're basically telling the reader like this value is not going to change. So usually you'll see something like const pi equals 3.14 something. So this is not going to change. Like no program is going to really change this. Or like const hours in a day 24. Like it's not going to change, and you can pretty much you can rest assured that this is constant. But if you did something like let time and something that you're going to constantly reassign to, then you would use a let. So those are the differences. So yeah, great questions. Any guesses as to what this will log? I went over this a little bit earlier. It is a little tricky. It will, good guess, it will log act locally just because you can think of the JavaScript evaluating entity as something that's very lazy, and it will just look at the closest one that it can find. So when we're logging console log message, it'll look for the closest message within its own scope, within its own local scope. And so it will find that it's called act locally, so it'll just log that. How about in this case right here? Yep, think globally. Because you gave it a message to look for, and it can't find it locally because it can find MSG, but it can't find MESSAGE. So it looks further out. It's lazy, but it's not a quitter. So it won't quit until it gets to the global scope, and then it has to quit because there's nowhere else to look. But in this case, it should be think globally. So again, you could think of the engine is going from inside out in each layer, and the first time it encounters something, it's just going to use that. So parameters. This is a confusing one for a lot of people. It was confusing for me for a while until I finally grasped it. Was basically parameters are no different than declaring something. So, for example, we'll go through it here to make it a little more clear so I can type. But we have a function shout message, give it a message, and say console log message. Go home. Basically, this is the same thing. Having this parameter declared as a function parameter is the same thing as doing let message equals message. That's the same thing. You could think of it like that in order for you not to be confused with. There's going to be a lot of questions in here that has like nested scopes, and it tries to confuse you by declaring certain things as a parameter. But even though it doesn't explicitly say this, you could imagine it like doing this, even though it's not actually doing that. And if you actually try to do it, it would give you an error because it would say message is declared, I believe. Yeah, message has already been declared because this having it as a parameter basically declares it already. But you could think of it like doing this. So if there was, there's another message, then you could think of it as let message 2 equals message 2. And then now these variables, these parameters are locally scoped to that function. Even though they're parameters and they're not declared in the conventional way, they're still interchangeable essentially with this. So with that in mind, yeah, parameters are also locally scoped. So in this case, what would be logged here? Any guesses? Good guess. It would be act locally. Because it looks inside out. So it tries to look for the first message that's closest to it, and that's act locally. So this is a kind of confusing part, so I just want to hammer this home. So basically, we're doing, let's just erase this. Basically, when we call this function, essentially what's happening is we're saying let message equals go home. We're declaring a local variable within the function here. It's basically saying let message. Can I type in here? Yeah. Oh, damn, I can't update it. But it's basically saying let message equals message. And when we pass that parameter, we're essentially doing the assignment there, and we're assigning the local message to be act locally. Get more practice with this. Yeah, it's a little tricky, but knowing that will help you in the long run. It's not explicit, which is why it's tricky, but it's just implicit, but you just have to trust that it's doing that, something similar to that. So now we're going to nest functions and make this really confusing, but Yeah, so in here, any guesses as to what this will log when we call this outer function? It's a little, it takes some time to grasp what's going on, but basically when we call outer, that calls inner. Yep, it'll be global, outer, and inner. So when we call outer, that calls inner, and when we call inner, that logs the global variable, which is global, and that's accessible because anything deeply nested can access everything else, can access all the scope outside of it, but it doesn't work the other way around. So, you know, the global scope does not have access to inner var or outer var, but the inner var has access to everything. So the deeply nested scope has access to everything that's outside of it. So it'll have access to global var and outer var and inner var. Global, outer, inner. Basically, when you're evaluating what your function has access to, it has access to everything outside of it. But when you're evaluating what your function has access to, it doesn't have access to stuff that's nested within it, but it has stuff that's it has access to everything outside of it. So the outer function does not have access to inner var. So it doesn't work, it doesn't go outside in, it goes inside out. Now we're gonna get a little trickier. Any guesses as to what collision will log? Outer, that's a good guess. It'll log inner because it goes outside. It like looks for the closest one, and the closest one is inner, and so it'll use that. If line 7 didn't exist, then it would be outer because outer is the next closest one. Again, you could imagine on line 5 that there's an expression that says let collision equals outer on line 5. You could say that that's pretty much there, even though it's not. Now, if there was no collision parameter on line 4, then it would be global. So it goes inside out. Let's see. This can get pretty harrowing, but how about in this case? What would this log? Any guesses? It would be outer. It would be global if we didn't have the parameter on line 4. But again, the inner function looks at its closest, at its own scope, and it finds that there's nothing there. So it looks at this outer scope, finds that there's collision because, again, we could say on line 5, it's let collision equals outer. So it finds that and it's just gonna stop there because it's like, I don't want to do any more work. I found my lowest hanging fruit. So Cassie said, but parameters are local. They are local to it's that function scope, but since you created another function within that function, that inner function has access to everything outside of it. So that's why it uses the outer. Yeah, I mean, it's local. It's local to outer, but since inner is defined within outer, inner has everything that outer has access to. Any guesses as to this, what this would log? Basically, it would log global. Because there's no outer parameter, there's no inner parameter, there's no local variable within inner. So it keeps looking inside out. It goes all the way to the end, and then it sees line 2, and it finally finds what it's looking for. Yeah, so basically this is just showing that we can go inside out, but we can't go outside in. So inner var has access to outer var and inner var. But the outer function does not have access to inner var because you can't go both ways. You can only go one way. And so the way that JavaScript works is it goes inside out, but you can't go the other way. So this will log outer and inner, and then it'll log an error because inner var is not accessible from the outer function. So yeah, we just, when we choose, so it's an error because we can't look outside in. So inner var is declared within the local scope of the inner function, but outer doesn't have access to that inner function because we can't look outside to inside. Like we can't go deeper into we can't access deeply nested variables from the outer scope. So that's why basically inner var is local to inner's scope, the inner function scope. It's local to that. So anything outside of that can't have access to that variable. So that's why it's an error. Can go over it a little bit more. Try to think of an example that's good. So say we have like a function secret manager. Inside we have secret equals does anybody have any guesses what this will log? Yep, it'll be an error. Secret is not defined because this outer scope doesn't have access to this inner function scope because that's part of what gives JavaScript a lot of power is you can basically have functions create their own scopes. And me as a developer, I can't access this variable and change it in some way. I know that this variable, when I call this function, will always be I love lemons, and nothing else has access to that to change it in any way so that what I expect, the I love lemons secret, can't be changed by someone else because it's local to the scope. It's protected by the scope. But if I didn't have this protected, if I just had my secret out in the open where everyone could see it, Damn, what happened? Okay. Yeah, so if everyone could see it, then they could maybe change it. And so I'm expecting my secret to be I love lemons. But if somebody changed it, now like now my secret's been exposed and it's also been changed. So, you know, if I were to protect it within here, then I would know that no outside force can access that and change it in some way. So basically, keeping these local scopes are also ways to just protect your variables from being accessed by um, you know by outside functions. Yeah, so we can go inside out, can't go outside in. The inner function still looks for a local declaration before looking at the next level of scope. Yeah, so all of these are just practice to really get your head around scope. But whenever we log something, we could say, oh, the outer var, it can't find within the local scope of inner, so it'll look out to the next scope. And that's there, it'll find outer var. Inner var, it'll find immediately. So I believe this is outer inner. Oh, I forgot that the parameter was called outer var. So that's why it's undefined in this case. That was easy to miss. That's definitely a trick question. But on line 7, we see that there's an outer var that's declared. So technically, let's say there's line 7.5 between line 7 and line 8. That line 7.5 would say let outer var equals outer var. But when we call inner, we don't pass that. We don't assign to the declared outer var. So if we don't assign anything, then that stays undefined. It's essentially saying let outer var without actually doing the equals blah blah blah. So now when we log outer var, it's undefined because of that parameter, which is essentially a declaration within that function's local scope. It's a little tricky, but does anyone have any questions about that? So George asks, can an inner function return a variable or calculation to the global scope so that another function can access it? Yep, definitely. It definitely, most definitely can. So in my previous example, if I returned my secret and I called it within the global scope, then that is yeah. So let me try that actually because you bring up a good point. Let's see. Let new secret. I mean, so if I just returned dang. So if I declared this and I returned secret, then I would have access to secret. So this should be I love lemons. But basically I've already returned out of that function, so I can't really do anything else. Like I can't, if I were to change this, so secret equals I hate lemons, that doesn't really change this scope because this function already ran to completion and there's no more scope for that function anymore. It's basically done running. And so it's not like I can change this secret or reassign this variable and have that affect this because this function's already done running. So yeah, good question. But in this case, you're returning it to the outer scope so that this global scope now has access to that secret, but you've already returned. And so this function is done running. And so secret is still I love lemons within the function, even though you reassigned it within the global scope. Within the local scope, it's still I love lemons. Does everyone get this example though? It's kind of tricky, but it's undefined. Outer var is undefined because even though on line 5 it is outer, it's looking at the one that's declared on line 7. And that is undefined because we never passed a parameter to inner. And so the declaration never had a corresponding assignment. So let's look at block scope now. Block scope is basically scopes that are created inside curly brackets that aren't functions. So basically conditionals. And so when we go in here, we can say, oh, we can access block because block is let block, that declaration and assignment is within that scope, that block scope. So when we console log block, within the scope, we have access to it. But when we actually try to get access to it outside of the scope, outside of the block scope, then we don't have access to it. So that is why we get a reference error when we're outside of the block scope. It's not that different from the functional scope. It's actually pretty similar. So if you use var, it ignores it. And so in this case, it will actually log both times. There won't be an error thrown because var is more of a, plays by its own rules, does its own thing. And it's convenient at times, but because there's no guardrails, sometimes things can get quickly out of hand. So if we go, so is it industry standard not to use var now? So that's a great question, Arthur. I would say that in coding, there's like no absolute rules. So it's not like you can never use var. That's not, I feel like every tool has its use case. And so sometimes you might want to use var. If you wanted that flexibility, I mean, it's tough to say that you can never do it, but I would say for the most part, a lot of people use let and const just because having those guardrails just prevents weird behaviors from happening and like unexpected behaviors from happening. And if you have things leaking out of the block scope, then that can sometimes be convenient, but at the same time, it can be confusing. So I would say in general, a lot of people now use let and const exclusively, but you're definitely going to run into some code that was written before all these new additions got attached onto the language. So you're going to have to learn how to work with var as well because you'll see it around and it's still in lots of code. Yeah, so Elizabeth said you needed to use var because let wouldn't work. Yeah, and there's cases where that would be the case. oftentimes you can use workarounds. So if let won't work, then you could kind of tweak things around so that you're not dependent on the var leaky scope feature. But yeah, there's definitely no hard and fast rule. I would say for the most part, though, people have been shifting to more towards using let and const because of that stability that it affords. So functions, what's cool about this is that, does anybody have any guesses what this will log when we call the function before we even declare and assign it? Yeah, it'll log yes, because it's almost like this hoisting thing. The function declaration and assignment happens before, like it gets hoisted to the way top. It's like gets a little rope and it pulls onto that rope and the rope pulls it up all the way to the top of the file. And then now it's pretty flexible now because we can declare a bunch of functions and we can always call it even before it's declared. This is only for functions though, not for regular variables, as we'll see. So variable declarations are moved to the top of their scope when you use var. We just saw previously that when we use let, that didn't happen. Yeah, so here it's saying functions defined with let or const can only be run after. So this is a little more strict, but this won't work because let isn't hoisted. I believe if we did var, it would still say it's not a function though, even if we used var, because if we use var, the declaration is hoisted, but not the assignment. The assignment always happens when it looks like it should be happening. So on line 6, that is when the actual assignment happens. So even if this was var, will this work? It still wouldn't be able to be called or invoked because the actual assignment that assigns it to be a type of function, that doesn't happen until line 6. So yeah, we'll go through some best practices here. So this is a bit contrived, but here we're changing the value of this global variable within the function. And so now when we call this function, always true is going to be false. So we won't log all is well. We'll log the else, which is throw new error. And the reason why this is confusing is because, I mean, in this case, it's not that confusing to know that this global variable was changed. But let's say we had in the wild, you might encounter something like, let's say we had that's why we use const as well, because that wouldn't be able to happen if you were using a const. So it was like that, and then you had a viral function. This is a virus, and it's just gonna try and reassign this to be, some crazy number that's gonna mess up all your math. But like the thing is, this won't work because I believe you can't reassign. That's why const is a nice safeguard to prevent like things like this from happening. But let's just say you decide to use let. Then when you call this viral function, then when you log pi, it's going to be different than what you expect. And in a small function, why is this not working? Pi is not defined. In a small function, in a small file like this, it doesn't really matter because, I mean, it's clear that this function is doing something that's bad, which is reassigning this global variable. But let's say you had a bunch of functions, like you had like hundreds of functions in this file. Like You just had a lot of things going on here, and it's just massive. And you're creating a function, right? Let's say you're tasked with creating a new function that calculates the area of a circle, and you don't see all these functions. Like they're all really far down the file. And so you're just like, okay, I'm gonna make my function that calculates the area of a circle um, that has a radius. Then you would just be like, oh, like yeah, I have pi right here. So let me just return pi dot or pi times the radius times the radius. But and then you're like going about your day, but some other code is calling this function that this different function and that reassigns the value of pi so that when you actually call this function, pi is different than what you expect. And you never want something like that to happen because then you're confused and you're like, but pi is 3.1412. I see it right here, but some other function changed it when it ran. Stuff like this happens if you're not careful about global. Like this is why there's all this talk about don't change global variables within functions, because when you're just writing your code, and it should be like this pi should be 3.14. It should never be anything different, and you should never expect it to be anything different. But if some other code's changing that, then that's just tough luck. It's probably going to be a bug in your program. So I mean, there's safeguards against this. Like as I mentioned before, you turn this into a const, so you can't reassign it even in other functions, or you could do other more protective ways to mitigate these risks. But as a general rule of thumb, when people are talking about that, that's generally why this is an example of why we shouldn't mess with global variables, because it could cause all these unintended side effects to happen when you depend or rely on some value to be that value when it's declared, and then something else changes it. That's really confusing. So yeah, you'd always want to create like some local variable. If you want, like in this case, if you want to play with something, just create your function and just do whatever you want in that function, because that's not affecting anything outside of it. Like code somebody else has written, you're not affecting that when you create local variables. So it's always good to just work locally within your own function and try not to affect things that are outside of that scope. So yeah, this person did a good job. They made their own local variable and they didn't touch the outside global variable. And that's a great use of best practices. And yeah, we don't want to clutter the global namespace with lots of variables. Again, if we are constantly declaring variables globally, then there could be a collision. You can't have let name equals David and then try to do let name. Like name is now no longer valid as a variable. So that's why you want to avoid cluttering that. Only declare variables globally if they need to be accessed globally. So if a bunch of functions need to access a certain variable, then you can create a global variable. Otherwise, it's just safer to declare variables within functions or within blocks so that you don't override things accidentally. So yeah, I mean, for right now, we're kind of working within these problem-solving environments, and so it's not as big of an issue if you're creating these global variables. And even in development, actually, there's a lot of safeguards so that you can't really declare global variables. I mean, it's hard to declare global variables now, even in regular development, because there's so many constraints and guardrails against that are just happening under the hood. But this is definitely something that's good to know. So yeah, that is the lecture for today. Scopes. And in order for us to really hammer this home, we're going to pair off. And similar to last time, I'm going to give you guys about an hour to work through these problems together in groups and pairs. And then afterwards, I'll have a brief review of the first couple of problems, and then we'll open it up to more review tomorrow. Or do we have class tomorrow? I think it might be Monday. Yeah, I think we have Fridays off. So on Monday, you guys will have a chance to review the later problems. So let's get right to it. Just stop this.